Hi, hello everybody. So this is the topic 5.5 and I've decided to call it section 5B because I'm going to show you here the expressions that may require multiple stacks or multiple techniques to factor. And remember, we have these techniques that we have to consider in this order, beginning with the greatest common factor, grouping, trinomials, and difference of squares. We'll see the sum and difference of cubes in the next section. So let's take a look at the first one, 27x squared minus 75y squared. I have some of these problems already worked out. Okay. So here's the problem, 27x squared minus 75y squared, and the techniques we have to check. And remember, the one that we must check first is greatest common factor. So the 27x squared minus 75y squared looks like difference of squares because I have two terms and a minus in the middle. However, between 27 and 75, I do have a common factor, which is 3. So in that case, I must factor 3 first. Once I do, I will get 9x squared minus 25y squared inside the parentheses. And how did I get that? Well, 27x squared divided by 3, 9x squared, minus 75y squared divided by 3, minus 25y squared. At this point, I have to ask myself, can I factor further? And again, the term inside the parentheses looks like difference of squares. I have two terms and I have a minus. So I have to factor the inside term by difference of squares. And I'm going to do that right now. And I will get 3x plus 5y and the same term 3x minus 5y in the second. And notice 3x times 3x is 9x squared. 5y times 5y is 25y squared. So in this case, we didn't stop here. We had to go one extra level and factor the parentheses fully to get the correct answer. Okay, so these techniques, you have to be careful because tendency sometimes is to stop factoring, but more may be necessary. So you have to be attentive in those cases. Second example, 81x4 minus 16. So again, I think I have that problem here already. So let's take a look. So here it is, 81x4 minus 16. Again, remember to always do GCF, grouping, trinomial, difference of square, right? And we go in this order, starting with greatest common factor. Well, in this case, I don't have a greatest common factor because there is no number that divides 81 and 16 together. So I immediately jump to grouping. This is not grouping because it's only two terms. It's certainly not a trinomial because it's not three terms, and it's difference of squares. So I will factor 81x4 minus 16 by difference of squares. I will get 9x squared here. Multiplied gives me 81x4. One is a plus, one is a minus, and 4 times 4, which is 16. I factor by difference of squares, I get the answer, and I ask myself, do I have to go further? Is there any more that I can factor? I can certainly not factor the first term, but look at the second. The second term is again difference of squares. So I have to factor 9x squared minus 4 by difference of squares again. And we do that. I'll just copy the first one as is. And for the second term, I open two parentheses. 3x times 3x is 9x squared. One is a plus, the other is a minus. 2 times 2 is a 4. So this is the correct and final answer for this problem. So in this case, notice that we had to use difference of squares twice. In the previous, we had GCF and then difference of squares. So it may happen that you have to use the same technique more than once, as in this case. Let's take a look at the last one. I don't know if I have this problem here, so I'm going to copy just in case. So I do have the problem here, so which is good. I'll have to rewrite it. Okay, so here's the problem: x cubed plus 6x squared minus 4x minus 24. I check GCF first. No, there's no GCF. It's certainly not trinomial because I don't have 3 terms, and it's certainly not difference of squares because difference of squares is 2 terms. But it looks like I have grouping. And as you can see here, I already grouped in 2 groups. So I'm going to factor the first group, and I can factor an x squared. I will get x plus 6. And I can factor something out of the second group. But remember, in grouping, I have to factor this sign, whatever it is, plus or minus. And I can factor a 4, right, out of the second group, 4x minus 24. I will get here x plus 6. Notice these two are identical, so I will factor that, just like grouping. And in the second parenthesis, I'll get x squared minus 4. Excellent. At this point, I ask myself, am I done? Did I factor everything? It looks like I factor a lot, but notice the second term right here. What does this thing look like? Yes, this is difference of squares again. So I have to factor that. There's nothing I can factor in the first term, x plus 6, so it stays the same, but the second term gets factored by difference of squares. So x squared, one is a plus, the other is a minus, and 2 times 2, which is a 4. And now this is my final answer for this problem. So in this case, we had grouping first and then difference of squares. So this may happen also. So you have to be attentive and not stop at this point because this would not be completely factored. This is the final and correct answer, right? Okay, so for these techniques that require multiple steps, always be on the lookout for possible multiple applications, either of the same technique or a different one.